Sorry for that interruption right there. So 32 goes into 192. How many times? I would say let's try 6. So 6 times 2 is 12, so you get the 2 there. And it looks like it's going to go in there. So 6 times the 2 is 12. 6 times that, 18. So yeah, hey, look at that. It works out like really perfectly. And so you subtract, you get a 0. We still have this extra 0, so you do need to fill in that space, remember, with a 0. So you get 60. Our answer is 60. X is equal to 60. So 19.2 is 32% of 60. So if you were to type this in a calculator, you could work it back and, check it. Or if you want to just plug it in, you can always check it that way, too. All right, now that takes care of section 6-7. We are now going to look at the next section. Dum dum dum. Next section we have right here is percent of change. This is not very difficult. It's actually pretty easy. So here we have the percent of change. This is ridiculously easy math, guys. So the percent of change is equal to the amount of change divided by the original amount. And basically this is used to see how much has something changed. How much has it increased by or decreased by, the percent value. All right, so let's take a look. So we're told here to find each percent of change and to tell whether the change is an increase or a decrease. And even though it tells you to do this second, you can actually do this first because you can tell really quickly what it's doing. So for instance, if it says, from 60 to 42, we start here, we go to here. Has there been an increase or a decrease? Obviously, there's been a decrease in the amount, but how much has it decreased by? So what you do is this. You say the amount of change. Now, this confuses a lot of people because they think, oh, I just take this number and divide it by this number. No. The amount of change, and you might want to write this somewhere in your notes. It might be helpful to write it up here. It's up to you. Or you might just remember this on your own. Either way. But the amount of change is equal to the first number minus this number. So the first number minus this number. It's basically the absolute value. It's the difference between these two numbers. You could look at it like that. So the amount of change is the difference between these two numbers. And the original amount is the amount we start with. So we end up with this right here. We have our original amount, which is easy to see, is 60. And the amount of change is, you could, like I said, just subtract this. And you would end up with 18. So 18 is the amount of change. We then need to turn this into a percent. So you could use long division. You could reduce it first and then divide. You could find if there's a way to get the bottom number to 100. There's a lot of different options we have. So I happen to notice that 3 goes into both of these. And 3 goes into this one 6 times, while, or actually, here we actually notice that it looks like 6 goes into both of them. Let's do 6. 6 goes into this 3 times, and 6 goes into this 10 times. I now have 3 over 10. If you want, you can use long division, but I know that if I times this by 10, I get 100. Anything over 100 is a percent. So this is going to be 30 over 100, which is equal to 30%. So the percent of change is 30%. There's been a 30% decrease, okay? So I'm just going to put a D right here, right underneath this, and box this in. This tells me that it's 30% and a decrease. Over here we do the same thing. So my original amount is 50. And it looks like that there is an increase of how much? Looks like about 24, okay? And so we need to find out what this is. And thankfully, 50 is an easy multiple to get to 100. We can times that by 2, times that by 2. And we end up with, looks like we're going to end up with 48. So we get 48 over 100. So that's equal to 48%. and it's an increase. I'm going to put a capital I right here. And so that's our answer right there. Let's look at a few more examples. Here we have 55 to 192. That's a big increase. And so we're going to put our 55. Whoops, I need to make sure I got plenty of room. So I'm going to put my 55. That's my original amount. And how much has it changed? Now remember, you can always just go to the side and do some subtracting to make sure. Take your bigger number, put it on top, and subtract your smaller numbers. Borrow there, that becomes an 8, that's a 12. 12 minus 5 is 7. 8 minus 5 is 3, and then we have that 1 there. So the amount of change that this has increased by is 137. So you have 137. So now we wonder, is there anything that can go into either one? Maybe the time like this is just a good time to go ahead and use long division to see how it goes in there. So we have 55 and we have 137. 55 can go into 137 exactly 2 times. 12. 2 times, and you multiply back and you end up with 110. You subtract and you're going to get your 27. You bring down another 0. Okay? So we got our decimal right there. I'm going to erase this because I got this all way too close together. Hopefully you didn't do that in your notes. So if you did, you know, maybe you need to make yourself a little bit more room than I did. You have that advantage. I don't. Mine's already pre-done halfway. Sorry. So multiply back, and it looks like that could go in a total of, let's see, what would that be? Definitely at least 4 times. Let's find out. 4 times that would be 220. Yes. And so if we subtract that, we end up with 50. Right? Yeah. And then so we just keep working this out, and well, we see that, let's finish this up. What is next up? We brought down another 0. Bring down another 0. It can go in there a total of 9 times. So 9 times this, so 9 times 5, 45. 9 times that, once again, here we go. And we subtract, and we're going to get another 5, right? If we subtract this, we would get 5. Make sure I do my math right. Well, then we have to bring down another 0, so 50 doesn't work, so we have to put a 0 here, and we do that. And we're going to get a 9 again, it looks like, which would then give us another 0, a 9, a 0, So this is one of those times where it's like, when necessary, round to the nearest tenth of a percent. So 1/10 of a percent, because of how this looks right here, we would have to, to put the decimal back 2. So you would end up with 249.1%, and it's definitely an increase. Definitely an increase. And you check to see if there's any mistakes in here. There might be a mistake, so you check to make sure the math's all done correctly and make sure you're paying attention. You see if you agree with that number. See if you agree with that number. Not saying there is a mistake. Not saying there isn't a mistake. I'm just saying, make sure you're paying attention. All right, so here we have 180 to this. So obviously, going from bigger to smaller, this is a decrease. So we're going to take our original number, 180, and we're going to put over it our 36, okay? So here we have 36. No, we don't put over 36. We find out what the difference is, so we go ahead and subtract. So I would have my 180 minus 36, so minus, borrow there, that becomes a 7, that becomes a 10, that becomes a 4, that becomes a 4, that becomes that. So we have this over 180. So I've now set this up for you, and what I want you to do is I want you to finish working this problem, and I would like for you to also work these two. So work this one right here and this one right here, and come into class ready to answer these questions and ask your own questions. See you then. Bye-bye.